So does anyone know how to do the first warm-up? We are going to factor here. Multiply add method. Good. So multiply to 30 and adds to negative 13. Anyone know the combination? Yes. Negative 10 and negative 3. So we do x minus 10, x minus 3. Remember that you need to go back and divide by your lead coefficient. The lead coefficient here is 1, so nothing's going to change. So that is actually our answer here when we factor. Any questions on this? No. How about the next one? It's a different method of factoring, actually pretty much the easiest one, I think. Yeah, you just take the square root of both. So what's the square root of 9x squared? 3x. So we have 3x and 3x. What's the square root of 25? 5 and 5. One gets a plus sign, one gets a minus sign. Order doesn't really matter. All right, so hopefully this stuff's coming back to you after your 2 weeks off. Any questions on these? All right, today we are doing section 6.5. It's all about the remainder theory and the factor theory. Basically what we're going to do today is a lot of dividing of polynomials. So we'll do long division of polynomials. We'll do synthetic division of polynomials. We'll talk about what it means when it has a remainder and things like that. The directions for problem number 1 say that we should divide using long division. So you probably remember long division back from grade school. The first number goes in the little box. The number you're dividing by goes outside. Special things to pay attention to when you're dividing polynomials using long division. You want them to be in standard form, and you want every term to be represented. So we need to start with our largest exponent, which in this case is x squared. Then you need to make sure you have an x term and you have a constant. Okay, let's say that, for example, there was no x term. You would say plus 0x. We still need a placeholder for each descending exponent. All right, so the steps are going to be written off to the right just so you can follow along. I think they are in your book somewhere too. If you don't feel like writing the stuff in the red, I would definitely make sure to focus on the stuff in the blue though. So the first thing you want to think about is, what do you multiply the x by to get 2x squared? So what would you multiply this by to get this? 2x. Okay? That needs to go above where you're... The next thing you want to do is you multiply. So you probably remember from long division, you multiply this number by this number and write it below. We do the same thing here, but you have to multiply each term. It's kind of like distributing. So 2x times x gives you 2x squared. 2x times the 5 gives you the 10x. And remember, it's kind of like columns, so all your x squared terms should be here. This should be a column of just x terms. This should be a column of just constants. Again, recalling what you did in long division, you actually subtract those terms, so we're going to change them both to minuses. 2x squared minus 2x squared gives you 0x squared. Negative 3x minus 10x gives us negative 13x. The next thing you want to do is you want to drop this down. We get a plus 1 here. And then you basically just do the process again. So now what would you multiply the x by to get negative 13x? You always want to think, what would you multiply this by to cancel out with this? Negative 13. That is a number without a variable. It's just a constant, so it needs to go in the constant column. Do the same sort of multiplying. So we need to do negative 13 times the x term. Negative 13 times the 5. Write them both here. I'll give you a second to catch up. It's kind of a long process, but like I said, it's not really mathematically difficult. It's just kind of remembering what to do. All right, next we want to subtract those terms, so we're going to change the signs. So now it's like negative 13x plus 13x, which is 0. That's why we picked the 13x, or the negative 13 in the first place. And then the positive 1 plus 65 gives us 66. 66 is our remainder. So our final answer is this. And then you might have learned back in grade school to put like R66 or something like that. We don't do that here. We take this and we turn it into a fraction. So it's the remainder that you get over what you were dividing by. And make sure you put a plus. For some reason people forget this. If this would have been a negative, it would be a minus. But that is our answer. I'll give you guys a second to look that over. Let me know if you come up with any questions. Alright, so we want to start with the same sort of setup. So the polynomial that comes first is the one that goes in the box. The one that comes second is the one that goes outside. Always double check that they're lined up from biggest exponent to littlest exponent, and each term is represented. So for example, if we start with an x squared, we need an x and then a constant. So we're good on that. Now we're going to think of, well, what would you multiply this by to get this? 3x. That has an x, so it needs to go above where your x terms are. Then we're going to multiply, so 3x times the x. That would give you an x squared, so make sure you put it in the x squared column. 3x times negative 1 gives you negative 3x, so that goes below your x's. Here's actually the step most people mess up on. Remember, you're subtracting each of those, so go through and change the signs and then combine the terms. So the x squareds are going to go away. That's the whole reason we picked 3x in the first place. And you'll end up with 2x in the x column. Now we repeat the process. So what would we multiply x by to get 2x? 2. So in the number column, you need a 2. Then you do the distributing step. So 2 times x is going to give us 2x. We'll write it right there. 2 times negative 1 is going to give us negative 2. We'll write it right there. We're going to subtract each of those terms, so I'm going to change the signs and then combine them. So 2x minus 2x, those are going to go away. 4 plus 2, since we changed the sign, is 6. So what you get up here is your answer plus your remainder over what you were dividing by. So this is our overall answer. What are your questions on this? We'll start to do them a little quicker because I think you guys are catching on. Remember, the first polynomial goes in the little box. The second one goes out front. We need to think of what we would multiply x by to get x squared. It would be x. So above the x column, you put your x term. X times x is x squared. X times 2 is 2x. Remember, we're subtracting each of those terms, so I'm going to go through and change the signs and then combine. The x squareds, we're going to cancel. Negative 2x minus 2x is negative 4x. Next, we want to think of, well, what would you multiply x by to get negative 4x? That would be a negative 4. Then you do negative 4 times x, negative 4 times 2. we're subtracting those, so go through and change your signs and then combine like terms. So we get a remainder of 14 on this one. Remember, we write remainders as fractions over what we were dividing by. So we get x minus 4 plus 14 over x plus 2. What are your questions? All right, now we're going to switch gears and look at synthetic division. Synthetic division is actually the same process as synthetic substitution. So the problems will look exactly the same. Now, here's the tricky part. Figuring out what goes in the box. The number that goes in the box is what you would get when you set this equal to 0. Okay? So it's like if we were solving for these, remember we set each factor equal to 0 and solve for x. If you set this equal to 0 and solve for x, you would get 3. That's what goes in the box. And then if you remember from synthetic substitution, you just write these numbers after the box. So you write the coefficient for the x squared term, then the coefficient for the x term, then the constant. I'll give you guys a second to write those down. All right, so now that we have it set up, remember we draw a line, leave a space because we're going to write some notes and some other things we need to keep straight there. But under the line is kind of the important number. So remember, we start by dropping the first number down. Do you guys remember what we do next? Multiply it by 3 and then write it in the next column. So 3 times 2 is 6. You write the 6 under the next column above the line. Do you remember what you do next?
Do the same thing.
Well, you got to add these two. So you do negative 5 plus 6, which is 1. 1 goes below the line. Multiply by 3. Move it up to the next column. You get a 3.
0.
And then you get a 0. Now, the answer isn't 210. We got to kind of take it a step further here. This is the remainder. This is the constant term. This is the x term. So when you write that, it actually turns into 2x plus 1. And that's our answer. So a lot of students get stuck on what variable goes with each term. A good way to think about it, it's always just this one minus 1. Okay, so if you started with an x squared, as you're writing your answer, the first one will be an x. If this would have been like x to the 4th, your first answer would be x to the 3rd. Okay, so just be careful on that. And then this one's the remainder. So this one doesn't have a remainder, so you don't need to worry about writing it as a fraction. If you would get a number here, that's where your remainder would come into play. All right, so this is a lot easier than long division, I think. That's why I said I wouldn't really use the alternative. I would get used to the synthetic option. But, I mean, really, it's up to you. If you wanted to do long division on all of them, technically you could. What are your questions on this? All right, let's practice some more. So what number is going to go in the box? That's the first thing to worry about. A negative 4. Good. It's what would you put in for x back here to make this term a 0? So negative 4. Then what am I going to write? 1? 2? Negative 15. Leave a space. Draw your line. What's next?
Bring down the 1.
Bring down the 1. Then what? Very good. Negative 4 times 1 is negative 4.
Negative 2.
Yep, add those, you get a negative 2.
8.
Multiply by a negative 4, you'd write an 8 under the negative 15.
7.
Negative 7. Good. So remember, negative 7 is your remainder. Negative 2 is going to be your constant. 1 is going to be your x term.
So it will be x minus 2.
Mm-hmm. Yep, x minus 2 minus 7 over x plus 4. Give you guys a second to catch up. Let me know if you have any questions. All right, like I said, the hardest part is kind of just the setup. So what number is going to go in the box on number 6? What?
Negative 2.
Negative 2. Very good. Then what? 3, 10,
8.
and 8. Good. Leave a space and draw your line.
3, negative 6, 4, negative 8, and then 0, I think.
3, negative 6, 4, negative 8, and 0. Yeah, you're right. Very good. So what would my overall answer be?
3x minus 4.
Where are you guys getting a minus 4? Yeah, 3x plus 4. Good. Close. Good. What are your questions?
None.
So the remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder is r, which is the same thing as f of k. So that sounds really wordy, but basically this is just describing synthetic substitution. So r is what our remainder was. So that was the last number you got under your line. Okay, so remember when the remainder was 0, that's like saying that if you plugged k into the function, you would get a 0. Okay? If the last number was 7, that means if you plugged k into the function, you would have gotten a 7. So we already kind of learned this. Like I said, this is basically just describing the process of synthetic substitution. It's saying whatever the last number is, that's the answer if you would plug k into the function in the first place.
Are we ever going to have to, need to write this down? Okay.
No, I will never ask you, what's the remainder theorem, and leave a blank. No, you just basically have to know what it means. And like I said, we've already kind of done this process before break. We just called it synthetic substitution. Any questions on that one? All right, here's the factor theorem. It says a polynomial f of x has a factor x minus k if and only if f of k equals 0. So, if the remainder is 0, then x minus k is a factor of f of x. Basically, that means it divides evenly. So if you don't have a remainder, what you were dividing by was a factor of the original polynomial. So again, sounds kind of wordy, but it's not too complicated, especially if you think back to what you know about long division, like from grade school. If your remainder was 0, whatever you were dividing by goes into that number. Same thing here. If your remainder is 0, the polynomial goes into the original function. Now, we're going to use what we just learned to do problems that are a little more complicated and involve an extra factoring step. So we're not quite done for today. We're going to use these theorems to take it a step further. All right, here's example number 7. Like I was saying, they're getting a little more difficult. You can see that the degree of the polynomial is going up. We're getting more terms. But we can use what we just learned to break it down a little bit. So this is saying that f of k is 0. Meaning that if we plugged 3 into this function, we would get a 0. All right, so that's exactly what we're going to do. We're going to do synthetic division, putting a 3 in the box. And setting up the problem. Now, I want to ask you guys for a second, if we were dividing to get this set up, what would we be dividing by? We wouldn't be dividing by x plus 3, we'd be dividing by x minus 3, right. So remember where this k came from. It's what they made x, what x would be to make what you were dividing by 0. So remember, that would be x minus 3 is where you get the k equal to 3. That's going to come into play when we get our final answer here. All right, so now we just go through the process of synthetic division. So we drop the 1, multiply by the 3, drop the 5, multiply by the 3, drop the 6, multiply by the 3, and we should get a 0 here, which makes sense because they told us when we plug the 3 in, we should be getting a 0. Okay, so whenever it gives you this information to start with, your remainder should always be 0 because we know this is a factor. Okay? The whole reason we wanted to do that, though, was to see what you'd get when you divided by that x minus 3 that we were talking about. Now, look back to the directions. Our overall goal is to factor this polynomial as far as we can. Can we factor this any further?
Yeah, sure.
Multiply, add, right? Multiply to 6, add to 5. Three and 2? Good. So if you double distributed from here, you would get this, right? That's not going to get us back to our original answer, though. We're missing a factor. Does anyone remember what that factor would be? And it comes from this right here. X minus 3. That's our third factor. Good. So if you went through and did the whole double distributing process, you would end up right here. All right, so this is kind of tricky. Like I said, today is just a lot of steps. If you can remember the steps, the math involved isn't too tricky. Just kind of remembering where you're going with it. Any questions? All right, here's another one we're going to look at. So again, our overall goal is to factor x to the third plus x squared minus 10x plus 8. If I gave you that and just said factor, that's not a problem that you know how to do. So you needed a little more information. I'm telling you that if you plug -4 in, you would get 0. That's what the directions are telling us, okay? Which means that x plus 4 would be a factor. All right, we'll have to remember that at the end. But for now, we're just going to set up the synthetic division. So what goes in the box? -4. Then you need a 1. And you need a 1, and you need a -10, and you need an 8. All right, I'm going to fill these in. I think this process is getting a lot easier for you guys. You seem pretty quick on it. So I'll write it on the board. You can check your work. Remember, we already know that -4 should give us a remainder of 0. So if you're not ending up with a 0 on the end, you did something wrong. All right, so the 1, the -3, and the 2 turns into this trinomial, x squared minus 3x plus 2. And then you can go ahead and see if that factors any further. Does it? Yeah, we can do -2, -1. And then what's the last factor we need to remember? X minus 4? X plus 4, yes. Remember, this is what you would get if you solved this by setting it equal to 0. Okay, so it's always just the opposite sign. All right, if you're ever like, I really have no idea if I did this right, double distribute. It will take you a while, but you should end up right where we started here. Any questions on this? All right, here's your homework. It's also on those sheets I gave you. They're kind of multicolored. Bring questions that you have tomorrow. You'll notice on the schedule there is not a homework check scheduled for this little portion of Chapter 6. I'm going to lump it in with the Chapter 7 homework check. So although it's not in the near future, it is still coming, so I would definitely keep up with homework. Any questions for me?